Good morning, students. You are welcome to CPS 516 class. The course is titled Soil Physics and Conservation. The course has two aspects: one, soil physics, and two, soil conservation. But I will be handling the soil physics aspect. In this class, I want to go through the course contents, which are: one, soil texture, soil structure, specific surface area, soil moisture characteristic curve, soil plant atmosphere continuum, soil water movement, soil air, gaseous exchange, soil thermal properties, which includes soil temperature, thermal conductivity, thermal diffusivity, thermal retention, and thermal retentivity. Now we go to the basic terminologies, revision of basic terminology used in soil physics as we have learned in CPS 301 class. Soil is a three-phase system. It has soil air, soil water, and soil solid, and this could be expressed on two ways: one, on mass basis and volume basis. As I said earlier, that this is just a revision of CPS 301. Soil texture per se is just a soil solid phase which consists of mineral particles. It differs in shapes and sizes like amorphous compounds such as organic matter and hydrated ions. The image shown here shows the clay particle, silt particle, although the sand particle is not there. It's just like the sand particle is like grain. The definition per se, it refers to the range of particle size in the soil. Also, you can say the field of soil particles. Field of soil particle, when you go to the field, when you take a soil sample and you feel it between your thumb and your first finger, you feel the field is maybe coarse and gritty or fine and smooth, depending on the soil particle. Alternatively or conventionally, it is a percentage of sand, silt, and clay particle in a sample of soil. When you want to determine the percentage of sand, silt, and clay in the laboratory, it is called particle size analysis, and otherwise called mechanical analysis. This is the procedure of separating soil into textural fractions, or separate, that is, sand, silt, and clay, by the method of G and O 2002. Here there are four steps, major steps. Number one, sample preparation. How do you prepare your sample? You go to the field with the aid of soil auger. You take your bulk sample. Depending on the depth of sampling, soil sampling depends on your motive, whether you want to sample for at 0 to 15 for shallow rooted crops, or 0 to 30, which is deep rooted crops. When you take the sample, you bring it to the laboratory. Note, you don't over dry, you air dry. After you have air dry, you sieve with 2 mm diameter sieve or mesh. Anything that is retained in the sieve is not regarded as soil, so you discard that. After that, you take 50 gram, you weigh 50 gram of soil into the dispersion cup. After that, you go to step 2, removal of cementing agents such as dehydrated oxide of aluminum and iron, organic matter, and calcium carbonates. Dehydrated oxide of aluminum and iron is not normally removed from the soil in the tropics, because in the in tropical region, the hydrated oxide of aluminum and iron form larger percentage of the soil particles, so you neglect that, you skip it, you move further to organic matter, removal of organic matter. This depends on the location of your soil, where you sample your soil. And when you sample under forest condition, there are bound to be high level of organic matter contents. So this is, you add hydrogen peroxide to it in order to remove the organic matter. Also, the calcium carbonate is abounds in soil from semi-arid and arid region, where there is accumulation of the subsalts as a result of irrigation practices. So you add calcium carbonate, you remove calcium carbonate with the addition of hydrochloric acid. The next step is dispersion. Dispersion is achieved by mechanically, either mechanically and chemically. When you use addition of chemical called calgon, sodium hexametaphosphate, when you had, you know already your sample is already inside the dispersion cup and you have removed the cementing agents. Now you add calgon, 5% calgon to 10 ml of 5 ml of 10% calgon to the soil sample inside the dispersion cup. After that, you now start stirring with electrical stirrer, or you shake with mechanical shaker for at least 10 minutes or 5 or 10 minutes. Within the range of 5 to 10 minutes, the soil will have been dispersed. After dispersion, you go to fractionation, which consists of sieving and sedimentation. Now it depends on what you want to achieve. If you want to separate the coarse sand from the fine sand, it means you are going to use 250 micron diameter sieve or 0.2 millimeter sieve, which will remove when you are pouring, you want to pour. After the dispersion, you pour the soil water medium into the sedimentation cup or sedimentation cylinder. After that, before you pour, because you want to remove, if you want to remove coarse sand from fine sand, it means you are going to use the sieve to separate the coarse sand from fine sand. After that, after you have separated it, you oven dry the coarse sand. You put it inside the oven at 105 degrees Celsius, and you wait to know the coarse sand, the percentage of coarse sand. Now, if you don't want to separate this coarse sand from the fine sand, you pour the soil water dispersed medium, that is the soil that has been dispersed inside the dispersion cup, pour it inside the measuring cylinder, which make up to 1000. You make up with water to 1000 millimeter. That is 1 liter cup. Now, after you must have poured it, you need salt, you need thermometer, you need hydrometer. This method, we have 2 methods. 1, the hydrometer method. 2, the pipette method. But the most convenient or most method is hydrometer method. Now, after you must have poured the soil water medium into the solution, into the sedimentation cup, you cover it with nylon and rubber band. You now firmly, you turn it up down for 50 times. After that, you put your sedimentation cylinder on the table. You measure the temperature of the medium, and after 1 minute, you insert your hydrometer, which measures the average concentration of the soil particles in the medium, in the suspension. At 1 minute, it is assumed that sand particle must have settled down. It will only remain silt and clay. And you come back after 2 hours, you insert your hydrometer again and your thermometer to measure the temperature and the average concentration of the particle that is in suspension after 2 hours. By that time, it is assumed that silt and sand particle must have settled down. You are only measuring clay particle in suspension. So after this, you will now calculate the percentage of sand, silt, and clay particles. Thank you. We'll continue in the next class.
Continue.